Hey everyone, today we're gonna be doing a late code question which is crawler log folder. So in this question they are saying late code file system keeps a log of each some user perform activity in some folder. So there are three types of operation like this dot slash, single dot slash, and some you can say directory name. So this dot slash means we need to move one folder less to the previous directory, or you can say parent directory. So we need to move to the parent directory. Dot slash means we need to remain in the same folder, and some directory name, which means we need to move to that particular folder. And we are given, like you are given some list of strings as logs which represent this type of operations in this array, which we need to perform in the ith step. You're saying the file system start with the main folder, you can say root folder, then the operation in the logs are performed. You need to return the minimum number of operation that needs to go back to the main folder after your changes operation. You perform some changes to this particular folder operation. So we have some directly like this. So let me show you like how exactly those things are looking. So let's say like we have some directory, we got some operation like we do some cd and we give some directory name. So let's say desktop for this case. So we gone to one directory forward. Similarly, I can go to some project directory. Now I have done like two operations here, like I have this desktop and project. Now they can be, there can be one more step, like I can do cd dot dot, you can say dot dot slash means cd dot dot. So I can say I can move to one parent directory. Again I can do cd dot dot. Cd dot dot means here like we are going back to the parent directory. This dot means no change. You can stay in the same location. So if you see in this particular example, I have this example over here. Like you will be starting from the initial main, you can say main folder. You will go into one directory, another directory. Again, you will do cd dot dot. It will come to the previous directory, and so on. So this will go on till you have some operations in this particular array. Okay. So we need to perform that operation, and we need to say, okay, at last, like if you see here, this particular case, like here it is saying, okay, you are at two directory apart from the main. That means you need two minimum operation to get to the main folder. So you can say the output is two. Let me let me show you with example of let me like draw and show you what exactly we are trying to do here and how we gonna be doing. So let's take the first example. So I have this logs array. Okay, this logs array have log, like initially it can go to directory 1. Okay, another it is going to directory 2. Again it is going to a previous directory dot dot, I'll say double dot slash. That means it can go to previous directory. Again, they are saying it can go to directory 21 slash. Okay, this slash means going to some directory. Again, dot dot, single dot slash. Okay, so we are having this. Now we have three types of operation. Okay, fine. What are three? Some directory name I can have. I can have this double dot slash and single dot slash. Now this particular means go to that directory. Okay, I can go to this directory. Now this means go back to parent, and this means no change. Okay, no change. Now if you see here, we are going like we are starting from main. Okay, we started from main. I started from main. I am at this folder. Now if this operation comes here like this, cd, I can say d1, it will go to a subdirectory called d1. Again, this d2 comes here, this d2 came over here, I need to go to that particular directory d2. Okay, now I got one dot dot slash. That means I need to come back to the parent directory. That means I need to reverse this direction. I just need to remove this particular case. Okay, so if I remove this case, it will come to this position at last known position, you can say. Now again I got this d1 slash 21. Okay, I'll go to the directory d21. Okay, fine. Now I got the operation dot slash. That means I can stay in my same position. Now, if you look carefully here, like if I say after D1, we gone to D2 in the first case over here. When we got this operation, we just remove the last standing position of a directory. So we know one thing, like, okay, this same operation we do in the stack. So let's say, like, instead of creating this folder, I can have something like stack. Okay, I have something like this as a stack. Now I can keep pushing my directory, like, okay, I am at this particular directory, D1. Again, I can go back, I can go ahead to directory 2. Again, when this dot dot comes, I need to pop the last known directory, or you can say come back to the previous case. So I can say, okay, remove this particular thing. Okay, either I can remove this particular thing, or in simple word, I will go back to my initial one, or you can say the previous parent. Now again, D2 came here, D21. So we push D21 over here, D21. Again, now this particular dot slash came here, that means no change required. Now if you see over here, we are iterating. If I say the time complexity over here, so we are using time complexity tc equals to what, order of n for iterating over this array, and we are using the space complexity order of n for storing all this particular directory in our stack, in the worst case if all are the directory names. Now if you see, like, we can still optimize this further. How? So what we can do, instead of, like, see what we are doing, whenever we are getting this particular directory name, we are just appending to this stack. Otherwise, if it is dot dot slash, that means we are removing something, and dot slash, that no change. Similarly, what we can do, instead of this pushing to the stack, we can say, if we get, if I get something like, let's say, I have, if our directory, you can say logs are given. Okay, if this log, in this logs array there are some logs, these are log, these are log. So if I say, okay, if log is equals to what, if I, it is single dot slash, that means no change, you can do continue. Okay, you can either skip or continue, depends on your language. Okay, else, if this log is equals to what, this backslash, you can say dot dot two, double dot slash, that means I need to pop. So I need to pop from stack. Okay, so instead of, like, popping from stack, I'll say, instead of pop, what I can say, I can decrement some count. So I can have this count equals to 0, and whenever I have this count inside this, I'll say, okay, if I have this count greater than 0, that time I can remove, like, decrement my count with 1 at last. If it is a directory, this case, okay, if it is a directory, this x, any folder name, that means I just need to increment my count. Okay, so I can do count plus plus. Okay, similarly, if I say, okay, in this case here, what I was doing, like, if I'm using the stack, I'm doing the stack.pop. In this case, like, if it is not a count, I'm was, in the previous case, if I say this particular case, the time complexity and stack part. So here I was using got stack dot, you can say push this particular log. Okay, so we remove this particular stack from here to reduce our time complexity. So let me show you with the code example. Okay, so let me code both of the example. So let's take the first example, like, first case. If we have this stack having time complexity order of n and space also order of n, we are iterating over this log. Okay, for log and logs. Now if this particular log, if I say log is equals to what, single dot slash, that means you can do continue. I'll say continue. If this log is equals to what, if this log is equals to double dot slash, that means I need to do pop from here. So we can do pop in one case, if we have something in our stack. Okay, if we have stack, we can do stack dot pop. If it is not there, we cannot pop, it will give our index error. Else, this is also else if. Okay, at last, if it is a directory, see, we cannot take any name as a directory, so we'll handle this in the else case. Whatever left will be as directory, so we can do stack dot pop, append. Okay, you can do stack dot push in another language. In Python, I'll do simply array. So I'll say, okay, it is like stack dot append whatever log I have. At last, I just need to return the length of stack, or size of a stack, like this will be the minimum uh, things I need to pop. So if I say here, the same I'll show you. Like here we have done. So till this, if we have done this, we have appended D1, we have appended D2, we have removed D2. Again, we have appended what, D21. So if I say, okay, these are the minimum pop, you can say minimum steps are required. You need to do, like if you say like two pops are required to go to the main, or you can say remove all those things. Oh, so they're saying like, okay, what is the minimum step required to go to the main folder? So if I say, okay, whatever things we have apart from that will be our main folder. So I'll say, okay, I got this particular thing. What I can do, I can just simply compile this code. So whatever things left in the stack, that means it will be our minimum steps required to get to the main folder. Now, if you see here, we have done this particular thing, it's compiled successfully and submitted this code. So if I show you the memory uses, where are that? So 1 second, let me show you. Okay, so here you see memory is using 16.84 byte. Okay, MB. Now if I remove this particular case, let's take like instead of stack, I'm using some count of value. So we will be using the same thing. So whenever we have count greater than 0, that time we will be decrementing our count. Okay, count, because like it cannot go far than main folder. When it is a main folder, if you see for one case, let me show you that case also. So let me draw you one thing. Okay, let's say like we have some folder like this. Okay, initially we can have, uh, I have three things. Okay, I have some directory name. Okay, some directory name. Again, this is our logs array. Okay, these are directory name. Again, I have what, dot dot slash. If again I give dot dot slash, that means, let me show you one thing. Okay, these three things we have in the log. So initially we are at main. Okay, we are at main folder. Okay, this is at main. When we got this D1, or you can say D, we gone to this directory. When we got this dot dot slash, that means we removed this directory. So I removed this one. Now we are standing at main, and we, if we do this dot dot slash, that means we will still remain in the main, because we cannot go further ahead to the main, like no more back directly in the main. So we are simply saying if we have count or we have something in stack, that time only we'll do our pop or remove operation. At last we will be like doing our count plus equals to 1. Okay, and here we need to just give the count. Okay, what is the steps you have the extra forward operations? So I'll say, okay, this is also fine. So if you look over here, like for the stack case, it is 16.84 MB. Let me submit this code using normal constant space, like we have done in a single constant space. You will look over here, like it is having no change, like both of the operation having around like same time and space complexity. Okay, but like you see, like the stack one is having just you can say 100 KB more. So because of the size of the stack, like if you see the, if I say the constraint, they're saying, okay, the log of length can go from 1 to 10 to the power 3, and the length of a log inside that directory name, it can go till maximum 1 to 10. So it is not that longer to store in the, if you say this is string to be stored in the stack, so it is like, you can say it's bit constant. So yeah, that's all for today's. Thanks for watching.